Hello everyone, welcome to a small video series on getting started with generative AI apps. This series is going to have total 5 videos. This is the first video. Here we'll see the development environment details, then how to install LangChain packages into Google Colab. I'll be using Google Colab as the development platform. It is available for free, and LangChain as an orchestrator. LangChain is an open source framework designed to build generative AI apps. This can easily integrate with LLMs like GPT, Llama, etc. And I'll be using GROQ API for interacting with LLM, that is also available for free. And in this video itself, we'll see how to build a very basic chat app which just translates the English input into another language. In the video 2, we'll see how to create a LangChain chat prompt template. There we'll see how to pass the variables dynamically and get the response. And in the video 3, we'll see how to build a very basic Streamlit app, how to install Streamlit. And for the Google Colab, to expose a particular web service, we can use local tunnel. We'll look into that as well. Then for Streamlit app to run, you need to have a separate Python file. So we will add that file into the Google Drive and access that from the Colab notebook and expose that using local tunnel. In the video 4, we'll build the actual language translator app using GROQ API. There we'll be doing the Python coding, but code is going to be very simple. And in the video 5, we will see how to convert that into OpenAI API. OpenAI API is not free. For this to work in OpenAI, you need to add at least $5 into OpenAI account. I'll show you that as well. But till video 4, you can do everything for free. So I'll be using Google Colab and GROQ API. And if you want to see the final output, so we will try to build an app like this. For example, if you just put a text in English and click on translate, so this will try to translate into all the selected languages. Here we'll get multiple language options. So let me just give translate. And if you want to verify this, we can go to Google Translate, and here we can see. Please consider this GenAI code purely for learning purpose, as this can be done even using Google Translator. Once we are familiar with the concepts, in later videos, we can even build advanced apps. So here, everything is running from Google Colab, and I'm exposing that using local tunnel. You can see it is a random generated URL. We can just quickly host these. We'll see all these details now. So first we'll see the development environment details. So I'll be using Google Colab as the development platform. It is a hosted Jupyter Notebook service, and you will get free GPU and TPU access for efficient model testing. So you can see here, I'm using the free account, and here if you click on this RAM and disk, here we can see it is giving 12.7 GB RAM and 107 GB hard disk. But this is runtime, and if you want more memory and disk space, you can even upgrade to Colab paid service. But for our use case, this itself is sufficient because we are not doing any processor intensive task. We are just consuming the LLM's API. We are just hitting their API and getting the response. So this is more than enough for our testing. And if you click on this and change runtime type, we can see even for free they are giving T for GPU and version 2-8 TPU. You can even change these, and runtime they are even giving R and Julia. And all these files will be available within your Google Drive. And I have already connected to my Google Drive. I'll show you how to access that, and we even have the option to add the secret. So I added my GROQ API key here, and I'll be accessing it using this code. So the advantage with Google Colab is no local setup required. It provides access even to your Google Drive files. One limitation is this require reinstallation of packages every time notebook restarts. For example, If you want to install a package or if you have some dependencies, you always have to run pip install. What I usually do is I keep this pip install command on top with all the required packages. And if you give -q, this will install the packages without a lot of terminal messages. And that is one limitation of Google Colab. And in the orchestration layer, I'm using LangChain. It is an open source framework for building applications with LLMs. This supports multiple providers like OpenAI, GROQ, Anthropic, etc. And this even provides chat prompt management and helps to structure workflows with chains. The advantage is this simplifies the development and integrates well with multiple LLMs. So we'll go to the documentation of LangChain, and here if you open the third-party integration, so LangChain is having integration with all these providers. You can see OpenAI, then GROQ, and to install the package you can just give pip install langchain-groq. So you can refer this document. Then if you want to see the chat model support, it supports all these chat models. In the first video we'll be using ChatGroq, and we can see some examples here. And in the LLM API provider level, we are going to use GROQ API. GROQ is an AI hardware provider. This provides access to multiple open source LLMs. You can generate API key for free from GROQ, and it is optimized for low latency responses. You can create an account, go to API keys and create API key. We'll go to the documentation to see the models it supports. So you can see it supports all these models. We'll be using this particular model, llama 3.3 70 billion versatile. If you go to rate limits, we'll be able to see the rate limits for the free tier. So request per minute, request per day, all these details you'll be able to see here. But you can generate an API key for free here. Just create an account and go to create API key and add it here. I have already generated an API key. I'll be using this particular key. Next is LLM model used. I'm going to use llama 3.3 70 billion versatile, and it is an LLM developed by Meta, contains 70 billion parameters. This designed for text-based tasks like multilingual chat, coding assistance, etc. And this provides high quality AI responses with low latency. And we can go to even the documentation of that. I'll go to documentation, then models, versatile, and here we'll be able to see the details. Next is front-end interface. This front-end interface is developed using Streamlit, and it creates a simple and interactive front-end. You don't need to have any kind of front-end development knowledge. So it is a quick UI development with Python. The limitation is it is not ideal for high traffic applications. Then this is required if you're running from Google Colab. If you are doing development from local, you don't need to use local tunnel, because from Google Colab, if you want to expose a particular website, you can use local tunnel application, and this creates a temporary URL for external access, and this is useful for quick demos and testing without hosting, and no server deployment needed. This will give you the instant access. And if you see my example, I just ran this command and it automatically created this website. It is temporary. Once I stop this, this site will become unreachable. So for the quick demos, you can use local tunnel. So now let's get started. I'll change the file name 01_01 basic chat. And here I haven't started the environment. If I click on reconnect, So now this is connected to the compute engine, and if you want to see this spec of this, you can see the RAM and disk space. If you want to check the Python version, you can give exclamatory and Python 3 hyphen hyphen version and shift enter, and it will be giving Python 3.11. This is the default Python available, and if you want to see the Python packages available, we can give pip list. And here we will not be having LangChain, but there are a lot of Google Colab related libraries and all available. We'll see how to use the secret key and Google Drive. Now, if you want to install the package, we can do pip install. So I'll give pip install LangChain, and if I give -q, and I can comment these to shift return, and it will be installing LangChain. Now I'll give the pip list again here. Pip. Now we can see LangChain in the list. We need to add the GROQ API key. I have already added here. I just added a new secret, and you can give any name here. Using that name, we'll be accessing the secret, and we can see the value of the key here. Now, if you want to use that within your script, here itself, they are giving some example. We can use that. Here I'll give the value GROQ, and I'll do a print here. Print. And if you don't give access to the secret key and try running it, it will say notebook does not have secret access. We can give access, it automatically enables it and prints the data. Now for accessing the GROQ API, we need to set the environment variable. So for that, what I'll do, I'll just import os, then os.environ, and then we need to set the GROQ API key. We'll go to the documentation. So here we can see we need to set the GROQ API key in this format. If you're doing local development, you can use maybe .env, or in this example, they are using get pass, so it will prompt for the API key every time when you run the script. So let me put this key here. Equal to, then user data.get, and I can give this key. Now we'll see how to use the GROQ chat model. Go to the documentation, and we need to import it. Here itself, I'll import it. So you can see here, notebook is saying that we don't have this package installed. So I'll add that package as well here. Run it. I'll run this as well. Next step is create a model. So simply by giving ChatGroq, you can create a model. So first we'll try that. I'll create a variable called model equal to ChatGroq. Enter. Code is running successfully. Now, if you want to see the details of it, in the documentation, we can see we have option to set model temperature and max token, all these options. But we'll check the default model available. To check that, we can give print model dot model underscore name, and we'll even check the model temperature. Sorry, it is not model temperature. We just need to give temperature. Enter. So the model name is Mixtral. So it is using this model by default, but we'll try using llama 3.3 70 billion. So here I'll manually set the model equal to and I'll set the temperature to 0. The default value was 0.7. Now if you see, the model has changed, but the temperature value became 1e minus 0.8. So here E stands for exponent. That means 1 into 10 raised to minus 8. It is a value very close to 0. So we'll see what is that. The temperature value controls the randomness of the model's output. If the value is higher, that makes response more creative. If it is lower, makes response more deterministic and focused. Here, if you notice, it was not 0, but it was a value very close to 0. And some frameworks avoid using exact 0 to avoid computation issues. Instead, they use a value very close to 0. So if you want to see the decimal value of this 1e minus 0.8, what we can do is we'll do a print 1e minus 0.8. We can even give 1e8. Then I'll give for the 8 positions, decimal positions. So this is going to be a variable, so I need to put a bracket here. So now let me just try running this. So now this is 1e minus 0.8. This is having 7 zeros in front of 1. So this is a value very close to 0. So we can comment all this. So here we have created a model. Now we need to import the messages. First we'll see how to use human message and system message. For that I'll import from LangChain core dot LangChain underscore core dot messages, import human message, comma system message. We'll go to the documentation. So messages are the unit of communication in chat models. So we can set multiple roles here, system, user, all these roles, and we'll see how to set even this in the chat prompt templates. Now, system message we use for setting the context and human message for the user input. And here, if we scroll down, we can see a system message is used to prime the behavior of AI model and provide additional context, such as instructing the model to adopt a specific persona or setting the tone of the conversation. So it is always better to use the system message to set the context. and human messages corresponds to the user input. And we can see some examples here. If you want to pass the human message, you can either give content equal to, or even if you give without content, it will by default consider this as content. And we can see all the other attributes, but we don't have to get into all this. All these we'll see later. Now we'll just try to pass a very simple message. So this is one example. So we can say that you are a helpful assistant, explains complex topics simply. And this will help developers to fine tune the AI behavior and improve the accuracy. Now let's write a very simple message. Message equal to, we need to put it in the list, and you can refer the documentation. Here either we can put it in this format or system message, and then within the parentheses we can give the content. So we'll try that option. I'll give system message, and within that either I can give content equal to the text, or even without content I can pass. Here I'll paste the instruction, comma, enter, and I'll paste even the human message. I just need to remove one additional double quotes which I added. Now if you want to get the response, what we can do is response equal to the model dot invoke, and we can pass the messages. I'll do a print of response. I'll run this, and I'm getting this error saying that system message is not defined. I have imported that here, but I did not run this particular code. Let me just try running this. We'll try running this again, and we are getting the response. So it is responding in Hindi, aap kaise hai. So let me put another question. So it is giving aapka naam kya hai. And if you want to change the language, you can do that. Now here we are passing static messages. In the next video, we'll see how to pass this language and the user message dynamically using the templates. I hope this video was helpful. Thanks for watching. See you in the next video.